let me just introduce Peter, our good friend and collaborator, clinical director of NutriPath Australia, and a consultant at WellLab. We work closely with Peter and NutriPath for quite a number of years. But in this presentation, we will be focusing on RGCC therapy. So last presentation, about a couple of weeks ago, we were looking at the testings, the various testing that RGCC offer on their CTC's range of products. So some of you folks were here, and if you have any questions that arose from that session, you can maybe ask first, and then we will going to be moving into more the therapeutic segments of this presentation by our RGCC. So it might be well worth give a bit of introduction again for some of those folks that join us, new that did not join us from previous session. So you guys can ask questions from the chat box if there's any. So at the moment, I don't see any questions as such. So we will proceed, and I'll hand over to you, Peter.
Okay, thanks, Edward.
No worries.
All right. So shall I just bear with me one moment? Sorry, everyone. Okay, so I'll just, do I click share screen?
Yeah, you are co-host now, so you can
okay.
share your screen indeed. Yes.
Okay, so effectively, welcome everyone. It was good to be able to present a couple of weeks ago on the range of tests that RGCC provide through NutriPath, and which we are certainly wanting to provide access to through Edward's group. To this evening's presentation is a follow-on to the talk from 2 weeks ago, where we moved to from the testing to the use or accessibility of the medical therapies that RGCC are also able to provide. So before we get to the therapies, I thought I'd spend just a few slides worth of information from last week as a review, like a recap of the previous webinar. So again, preface everything by saying the work I present tonight is the work of Dr. Ioannis Papasoteriou, the Medical Director of Research Genetic Cancer Centre located in Greece, also known as RGCC, who I guess they began their operations in 2004, and over the period of time, the last 15 years, they've grown to become a global leader in the provision of the specialised cancer tests, and now the medical therapies. And in due course we're they're looking at introducing a range of high quality supplements related to benefiting patients with cancer. They have facilities in Greece, England, Germany, and India. So they're quite a growing laboratory entity. NutriPath is their distributor in the region, and we've been distributing over the last 5 years or so for them. So as I said, a summary from part One, the use of the CTCs, circulating tumor cells, they can be isolated very effectively using a combination of selection assays through what are known as positive and negative selection processes to get a really high quality specimen that you can use not just for immunoration, but also looking at characteristics of these cancer cells. The test methods that are used have a low level of detection and high rates of sensitivity and specificity, as well as a high positive predictive and negative predictive values. As I mentioned, yes, we can not only enumerate or quantify CTCs, we can also look at their genomic and epigenetic phenotype. We are able to culture them and utilize the cultured CTCs to perform chemosensitivity assays against the common chemotherapies, immunotherapies, natural and biological substances as well. And other tests can be used for other tests to predict sites of metastases. We can use the CTC tests for either early detection or ongoing follow-up of cancer patients. So they're not specifically for one type of patient. They can be used at various points through the progress of the disease. Importantly, they can be used in designing a personalized treatment protocol for cancer patients, not just in determining the best chemotherapies or cytotoxic agents, but whether they're going to be benefited by immune therapies, which biological natural substances are going to be beneficial for them. Will they be benefited, or will they get a good outcome out of radiotherapy and or hypothermia? So there's numerous benefits in looking at these sort of assessments, in offering multiple options to cancer patients. So the basic CTC tests were the OncoCount, which is purely used as a ongoing monitoring of the levels, the presence and the levels of the CTCs. The key simplistic CTC test is the OncoTrace for practitioners. It's the test that you would use as an early detection test, as well as from time to time a follow-up test, because it not only gives you the presence and concentration of the CTCs, it allows you to also get a lot of information about the immunophenotype of the cancer cells. And what do I mean by immunophenotype? Well, we can define whether the cancer is hematologic or non-hematologic in origin. In certain cases, we can also determine from the CTCs where the organ of primary origin, the primary is. From the CTCs, we can determine whether they have resistance capabilities. In other words, will they be resistant to the therapies that are used against them? And also whether they pose a high risk or low risk in terms of metastases. The OncoTrail is very similar to the OncoTrace, except that it's only used as a follow-up tool once the origin of the primary is known. You may see that I sort of put in brackets for OncoTrace question mark screening. We get practitioners asking us, can we use it as a screening test? Although it's not designed or validated as an early detection test. We have practitioners who do use it for that purpose, and they have gotten, they've picked up conditions quite early on. The only dilemma there is that as practitioners, you need to be aware of what might follow on thereafter in terms of if you were to send the patient off for radiology, the radiology may come back as negative, and they'll be questioning why you wanted it, because the CTC test is far more sensitive than the radiology technologies. And the 3 chemosensitivity tests that RGCC was able to offer were the onconomics, and that's where we assess the CTC's gene expression and their chemosensitivity to the conventional cytotoxic chemotherapy agents. The onconomics extracts profile assesses the CTCs against the natural substances and biologicals, and the combination of those two is the Onconomics Plus, which is the full profile. And when you order that profile, you may add to it 5 additional natural substances of your choice for RGCC to analyse at no additional charge, but it's only for that profile. And the other test that we talked about a couple of weeks ago was the pharmacogenomic test, which is used in combination with the chemosensitivity testing to personalise even further the patient's possible treatment plan in terms of the best agents to use. So that we very quickly, there were several other profiles of testing that RGCC were able to offer, tests to assess the immune system, and we'll talk more about that when we get into the body of the medical therapies. The Metastat test, which looks at potential organs of relapse and metastases. The Prime Spot test, which we will also talk about shortly in the medical therapies discussion. And there were a couple of other tests there that look at chromosomal aberrations and the mutational burden and satellite instability. All right, so that was a summary quickly of the talk 2 weeks ago. Edward, you mentioned that some of the listeners may have questions from back then. Is now a good time to cover those?
Yes. So if anyone have any questions from this presentation so far, which was mainly a recap from last presentation, do ask. But I do remember Philip, one of the participants. Let me see whether he is here. Philip, I don't see him here, but he did ask I think the false negative percentage, which you did mention to me.
Yeah,
about that. Yeah. So, but he's not here anyway. So
okay.
So, but I don't see any other questions. So you can just
continue.
Yeah, proceed, and folks will ask the question as they arise.
Sure. Yeah. So yes, as we said, RGCC also have another division of their entity that has developed a range of medical therapies, and we as their distributor have been offering, we've introduced them to the region in the last 12 months only. Historically, we were not familiar or not familiar well enough about them to be able to introduce them and promote them. But in the progress of the company and the development of time, we've now introduced them and have been offering them in the region for the last 12 months or so. So they have 3 key therapies to offer cancer patients. The first is what's known as SOT therapy, supportive oligonucleotide therapy, SOT therapy. And that's just an example of a vial of SOT that they would send you. The second is autologous fragmented tumor vaccine that is made out of the patient's own CTC cells and then administered back into the patient over made up of 6 doses. And the third product is the dendritic cells, CD4 and CD34 cells and iPSCs. So we'll go to the first product, which is supportive oligonucleotide therapy, SOT. And what it does is selectively silence genes that are overexpressing. So as we know, I guess according to the central dogma of replication, we know that DNA generates the production of mRNA through the transcription process, and that ultimately leads to translation and synthesis of peptides, which ultimately form proteins. So it's when you look at these 3 sections or parts of the process, it's clearly inappropriate to alter the DNA because this contains very complex information. It's also effectively the hard disk of the human computer. So we really don't want to touch or alter or silence the DNA. The proteins, well, we could target those and stop them somehow from developing and progressing. However, the issue we have there is that the RNA that makes the proteins is still there to produce more. So it's getting rid of the proteins is a defeatist process. So really targeting the RNA would be the most appropriate process to silence the production of these unwanted cancer proteins that are being produced. That said, we need to make it clear that SOT therapy is not gene therapy because no gene sequences are altered and there's no damage or alteration to the patient's cellular DNA. So all we're doing is interfering with the production of the proteins by silencing the mRNA of those proteins that are of those genes that are being overexpressed. That's what we've got to target. So what we have is the traditional drugs attacking the proteins, which is really the the final, they're working from the end, at the end point, rather than working further upstream, where they could have a bit more effect in preventing the development of those offending proteins. So we begin by producing a small interfering RNA, siRNA, in a long double-stranded form. And effectively, when introduced into the body or the system, we get what's known as a dicer. This is an endo-RNase that effectively breaks down that long double-stranded strand of RNA into very small sections of around 18 to 20 base pairs in length. These small interfering RNA strand or sections of the RNA are then bound to the Argonaute, which is a replicative protein that is circulating in the body. And the Argonaute proceeds to unwind the two strands of that siRNA into what are called the guide strand and the passenger strand. The passenger strand is then released. The guide strand remains bound. The passenger strand, being on its own, is then broken down or degraded by other endo-RNases. And it's degraded, so it's of no further purpose. So the Argonaute, with that guide strand, become what is known as the RISC, the RNA-induced silencing complex. This product then moves around within the cell or in the body and finds its target mRNA, binds to it, and causes it to be broken down, and then thus inactivating that target mRNA from performing protein expression and development. So that, in effect, is how it works in principle. SOTs can be used in clinical practice. In particular, in cancer, they're used predominantly where there is a low to medium burden of the disease. Where it's at an advanced stage, its effectiveness isn't as high or as optimal as it is in the lower to medium burdens of the disease. So SOTs can also be used in chronic infections, whether they be viral or whether they be bacterial, and in particular, they are quite effective in the treatment of Lyme disease. We have met with practitioners from Europe and from the United States at RGCC events, and we've been lucky enough to hear about their experiences in using SOT therapy in the treatment of their chronic patient or Lyme patients. And verbally, they've told us that they've been using the products for years, and they get good results out of it, and hence, they persevere, with and continue in the use of SOT therapies for Lyme disease. So, as it's clearly, quite effective against the condition. We also know that SOTs are used in respiratory diseases, and more recently, trials had begun in certain neurological conditions. I believe they're looking at things like Parkinson's and Alzheimer's. So for SOT to be used in cancer, there are prerequisites. Not just anybody can have these sorts of therapies. So with each therapy, there is usually a prerequisite either test or eligibility criterion that needs to be met by the patient before one can order these sorts of therapies. For cancer, it's obviously the patient needs to have a positive CTC count in the last 6 months. And it has to be an RGCC CTC count. They won't accept another company's CTC results. And that would be through either an oncotrace, an onconomics, or an onconomics extracts report. For chronic infections, again, the prerequisite testing is required, and it can either be a prime spot test or this is a very new test from RGCC called PALDI-SPOT. And you'll see the difference shortly when I show you a couple of example reports. Those two tests are available through RGCC. They will also accept a positive PCR test for either viral DNA or Lyme DNA from a third-party laboratory, as long as it's within the last 6 months. We get questions as to, will RGCC accept ELISA results or Western blot results? If there's no other way around it, they may, but it'll be judged on a case-by-case basis, because as much as the antibodies at present, we know that antibodies persist in the body for very long periods of time. So we need something, some sort of result, indicative result that is very recent, in order to be eligible for the therapy. So this is an example of their prime spot report. As you can see here, we have a positive result for EBV, the virus. What you can also see is that there are actually 2 results for each organism. One is a serum result, and the second is an intracellular result. So we know that viruses and Lyme are clever little beings, and they tend to try to evade treatments, etc. So hiding inside cells is not an uncommon practice. So RGCC are able to test both the serum and intracellularly to identify the presence of either the viral or the Lyme DNA. So if you had a patient that had multiple chronic infections, you would more so go with a prime spot test rather than the PALDI-SPOT. The PALDI-SPOT is predominantly for Lyme disease, as the LD in the middle of its name, in capitals, Lyme disease. That's probably why they named it that way. It looks at all these different species of Borrelia, Bartonella, and Babesia. So here we have, a positive result. The CT values that you see on the right-hand column, there is an index of whether it's a low or high grade infection. So we've identified that we are eligible for SOT therapy. So how is it going to be manufactured? Once RGCC have the sample in their possession, they run a microarray analysis on the cells, and that will give us an indication of which cells or which genes are being overly expressed. We want to silence these overexpressing genes. So the microarray looks at overexpressed genes in these 3 key areas of the hallmarks of cancer. Once the genes that are overexpressing are identified, they need to be validated by a process called knocking down. That is a laboratory simulation, an in-laboratory simulation process of what might actually happen in the cell. The small interfering RNA candidates that they define get sort of tested against the cancer cells to see if they have, what sort of effect they do have on them. And through this process, we're able to eliminate the poorer performing SOT candidates to eventually reach a selection of a single SOT that is the one that gives the best effect. And this is the algorithm or process that they use. They do the microarray and they wind up with about 150 odd candidates. They then start to narrow it down by different processes. The in silico validation process at point 3 here is where they use you may have seen it on television at times. They use computer modeling to assess the effectiveness of the SOT therapy against the target mRNA to see that it actually binds really well or whether it doesn't bind well. Further along, there are other techniques. The validation process looks at how the final SOT candidates perform. Do they have a really good binding affinity, and do they have efficacy against these cells? So there are criteria about determining which candidates are poor candidates and others which eventually become the successful candidate because they are the most specific, robust, and stable form of the SOT. Now, we need to also remember that the cancer gene expression is changing progressively over time. So at the point in time that the SOT is made, it's fixed in its structure and nature, but the gene expression of the CTCs is changing, which is why once it's manufactured and sent to you, it's important that although the product has good stability, it needs to be administered relatively soon after it's been received, like within the first 4 to 6 weeks. You don't, although it is stable for a longer period than that, you don't really want to administer it 2 months after you've had it made, because it may lose some efficacy due to the ongoing change in the gene expression of the CTCs. So, for example, at an initial assessment, we determined that the BCL, the microarray revealed that the BCL gene was overexpressing. A SOT was manufactured, etc., and that's what was administered. Upon re-evaluation of the patient, possibly between 3-6 months down the track, it was shown that BCL had been down-regulated by the SOT. However, a new gene had taken over being the driving entity, the TP53, so that became the next target for SOT therapy for that patient. So it's important to understand that it may not be only a single SOT that gets used that can assist the patient. It may require, it will require a review, and where we see that something else is driving the process, an alternative product may need to be manufactured down the track. And obviously, RGCC manufacture all of these on their equipment, and they run a GMP certified facility in northern Greece. I've been there and seen the facility. It's quite impressive. So yeah, you can be assured of excellent quality of a product. So we've manufactured our SOT and it needs to be administered. But in getting it into the body and to the target, there've always been challenges, but over time these have been addressed and solutions have been found to enable SOT therapy to become more and more optimal in what it does, and thus beneficial as an option for cancer therapy. Importantly, the main challenges were to not allow it to be degraded by endonucleases within the body, because SOT is an oligonucleotide. It's a natural, it's a natural nucleic acid, even though it's it's synthesized. And we also want to ensure that it gets good binding. So that these have been the various challenges that researchers and scientists have had over the years in their development of SOT products. So toxicities was another, but then oligonucleotides are naturally occurring products, so they're the same. The SOT oligonucleotides are very similar to what we have within our bodies, so it's not an issue. And to protect the SOT from the endo and exonucleases, the ends of the nucleotides were polymerized to prevent rapid degradation from the enzymes, which allowed them to have a longer lifespan in the body in their search for their target mRNA. In developing the siRNA, there was always the possibility of it being capable of targeting more than one type of mRNA, which would have been undesirable because we only wanted to find and attach to and silence the specific overexpressing genes. So the improvements came in the lead-up work in terms of the validation and the knockdown processes to ensure that from the 150 candidates getting down to the final successful candidate, those processes had to be improved and improved and improved over time, which is what's actually happened. And as I mentioned earlier, this is what the validation process involved. SOTs can be delivered by multiple routes, but the more commonly used one is the IV methodology. So SOT is, when ordered, it comes to you in a small single 1 ml vial. In the bottom of the vial, in the conical base, is a tiny crystal. You have to look really, really carefully to see it, but it's there. In this crystalline form, the SOT is very much stable for several months, but as we mentioned, that's also an undesirable thing because you want to use it as soon as possible to get the best effect on the cancer cells. And once it's been reconstituted, once it's been reconstituted, it has a 21-day stability. Before it gets to you, it undergoes integrity control, quality assurance processes to ensure that it is suitable, and safe for the patient to have. And it comes with QA certificates for leakage and for sterility, so there's no bacterial or yeast type contaminations in the specimen. Yes, it's just repeating what was said earlier about utilising the SOT as soon as reasonably possible after you receive it, in order to minimise the change in the genetic expression that it was designed against. So this is an outline of how it is prepared. So to the 1 ml tube, we add 1 ml of water for injection, and we allow it to dissolve. Thereafter, it's then further made up with another 9 ml to a 10 ml total volume, which is then added to your IV for administration. And this is a list of things one should not do in getting the SOT ready for use in terms of it, and through its reconstitution. We don't want to heat it because heating and sonication will destroy the product that has been manufactured and paid for, so to speak. Only water for injection, saline, etc. It does not interact. The SOT does not interact well with non-polar type solutions. So, one needs to be careful. Once you've made it up, if you choose to split the sample, it should be split there and then, rather than thawing, taking out and refreezing. The refreezing process will rapidly deteriorate the SOT. And obviously, the SOT is designed for one patient and one patient only. It cannot be used for anybody else, irrespective of how similar their condition may be. And in terms of follow-up and review of the patient, there is a recommendation of between 3 and 6 months reviewing, and one needs to be looking at some of the more traditional markers, like sodium, potassium, LDH, in terms of how the patient is progressing, either an onco count or onco trail test to monitor how the CTCs are going. Now, based on the outcomes, as you can see down in the bottom of this slide, it also gives you indication of what action to take based on the sets of diagnostic results you get in the follow-up process. Side effects. Well, they're quite minimal. Most people have reported headaches and sometimes even mild flu-like conditions or symptomatologies, and these are easily avoided by pre-medicating, preparing the patient before the IV, and also the use of paracetamol as well assists in easing potential headaches and pains. For longer term issues, etc., and tumor lysis syndrome is a concern, but as long as the patient is being monitored, where it's identifiable, there are simple protocols that can be put in place to minimise that effect. And these are just some of RGCC's recommendations as to how to monitor the patient and what to look at addressing where TLS does appear. This is a slide they've sent me that shows that after 2 applications of SOT, this tumour had essentially diminished in size considerably. Although this statistical chart is somewhat a little bit out of date, it's the only data I have in terms of the successes they've had. the rest, we've heard verbally from practitioners, and we're awaiting more up-to-date data from RGCC. But we've only heard positive outcomes in the use of SOT therapy. We now move to autologous fragmented tumor vaccine. So the vaccine is manufactured from the patient's own CTCs. Its purpose is to stimulate the immune system to generate an immune response against the CTCs. So the vaccine, once administered, it recognizes proteins on the surface of the cancer cells and binds to them. The immune system recognizes these proteins and then initiates that immune response against the cancer cells. And its role is to stop tumor growth, prevent a reoccurrence of the condition. And tumor cell vaccine can be used synergistically with other treatment modes that might be in place. I did say that the cells could be autologous, but they can also be allogenic or lab grown. Just able to provide slight variations of their vaccines. And they can be in the form of either whole cells or fragments, but we know that whole cells tend to be less immunogenic in that they suppress the immune system. So the fragments produce an overall better anti-tumor response, which is why the fragmented cell vaccine is the much more preferred option. In this instance, there are contraindications as well as eligibility requirements in having the autologous vaccine. So one needs to have, the patient needs to have a well-functioning immune system so that it can elicit and stimulated to elicit a good immune response. The prerequisite test that's required is the RGCC immune frame test, which assesses the current status of the patient's immune system. If that proves successful, thereafter RGCC will need an additional 30 to 50 mils of blood in order to manufacture the vaccine. Ineligible patients are those that show a poor immune system, they've been on chemo, radiotherapy, or have other conditions as listed there. So it takes about 8 days to produce the vaccine from the patient's tumor cells. The product is delivered as 6 vials, 6 by 1 ml vial, in a lyophilized form. Again, there are quality assurance certificates for contamination and potential leakage of the product. And the schedule of dosing is over a 5-6 week period, and one assesses it. The administration process is either intravenously or subcutaneously, and a reassessment of the patient's progress, CTC/immune frame test at between 3 and 6 months. In summary, the autologous vaccine can be used for most types of cancer. It is quite safe in that it's a product that's manufactured from the patient. The adverse reactions are generally low grade, level 1, so then nothing serious there. It can produce a good immune response. Okay, the third product are dendritic cells. Actually, before we go to the dendritic cells, so the last two products, the SOT therapy and the autologous vaccine, they both come in a lyophilized form or crystalline and lyophilized forms that are temperature stable and not hugely time dependent or critical. So the ability for RGCC to ship to KL is really good. It's been done and it's proven. So you can feel confident that their product can be ordered and shipped from Greece to KL in a matter of days.
Peter, and also to Jakarta, I presume, because we have a number of doctors from Jakarta as well here.
It shouldn't be an issue in terms of stability of the product. For Jakarta, we need to test the process.
Yes.
What we've done historically with RGCC is that we have tested we've done dummy runs to evaluate that yes, we can ship it and get it into the country in an appropriate time frame with minimal or no holdups. And we've proved it for Australia, we've proved it for New Zealand, and we've proved it for Malaysia. We've not had an order from Indonesia, but
shouldn't be a problem.
Yeah, it shouldn't be a problem if it hasn't been a problem for everywhere else in the region. But before we commit to an actual patient, we will do a test run.
Yes, do a dummy one.
Yeah.
We'll get that organized.
Sure. The same at the moment, though. The same cannot be said about dendritic cells. We've tested it for Australia and it works. We've not been successful in proving it for any other country in the region. And we'll come to that a little bit further down in the talk, but I just want everyone to know that SOT and the autologous vaccine, there is no issue in getting it to you in a timely manner and without any loss of integrity of the product. Okay, so let's move on to the dendritic cells. So dendritic cells, they are they're cells that originate from monocytes, from white blood cells. And they are typically what are otherwise known as antigen presenting cells. They find the antigen, bind it, and then present it to the other white blood cells, the T and B cells, to generate immune responses. So, what RGCC do is, from the patient's blood, they extract the monocytes. They grow them in tissue culture, and they give them nutrients, etc., to differentiate them into immature DCs. Then, with the CTCs, they crush them and produce a tumor lysate, upon which they then stimulate the immature DCs to become mature DCs and active DCs that are very much specific against the tumor fragments. From there, they are isolated and they are then packaged and ready to be sent back to the practitioner to administer into the patient. So, it's a fully customized, mature DCs for the patient. And we'll need, again, a good amount of fresh blood. I think it was between 30 and 50 mils is required in order to produce these DCs. Again, eligibility, similar to the vaccine, we need an adequately functioning immune system. And again, we're going to look at the immune frame test to determine the patient's eligibility. And yes, 30 to 50 mils of fresh blood. Obviously, where we see that they've had chemo, radio therapies, or immune system suppression or cachexia, they are, and the others, they're ineligible for the manufacture of DCs. So the immune frame tests, again, it tests through two platforms: the ELISA platform to look at cytokine production, and also flow cytometry, which looks at the presence of particular cells in the peripheral blood, monocytic cell types. So its primary purpose is to see whether there is a development of immune suppression or cachexia. You know, where there is an upregulation of TH3, where we have suppressed immunity, etc., that's quite unfavorable, and the patient will not respond well to the DCs if they were manufactured. It would be a poor outcome, and it just wouldn't be appropriate. The therapy would not be beneficial. The second thing it looks at is the presence of dendritic cells. So what we're looking for here is where there is upregulation, that's a positive outcome, and that's an indication that the patient will benefit, can have the DCs manufactured, and there will be a good outcome from it. Also, the development of specific humoral immunity. Again, we want to see this section of the report upregulated, and this cellular immunity, where we want production of interferon gamma. So these are all important items about the patient's immune system that we need to know before we can consider having the DCs manufactured. Because it basically tells us that the patient will respond or won't respond to immune therapies. And we don't want an immune therapy that is is spontaneous and short acting. We need it to be lengthier and progressed over time. Again, in the production of the DCs, there's a bit more quality control that goes into assessing the eligibility, where an out-of-date tube is used, or there's been a leakage in transit, they won't, or the blood has clotted. These samples will be rejected and will need a recollection. So they do require sterile type specimens, etc. Once they have the sample in their possession, they will look at, again, bacterial yeast contaminations to ensure that they've got a good quality sample before they manufacture. It'll take about a couple of weeks to get the product made up. They routinely manufacture 2 doses. The first dose they will ship, and the second dose is stored in liquid nitrogen until it's requested by the practitioner at some point down the track. And the dosage interval is about 3 weeks. The assessment of content of DCs is measured by flow cytometry. So before the product goes out, it's run through a flow cytometer to ensure that they got a good quantity produced to send out for usage. And again, the quality control measures. So it arrives as a 5 ml clear liquid. Now, unlike the first 2 therapies, this dendritic cell therapy has a very limited lifespan. It'll be shipped out to you on a Monday from Greece. It will arrive in KL or Jakarta on a Wednesday or Thursday. But the patient must be available to have the therapy administered either on the Thursday or the Friday at the latest. It cannot wait until a Saturday or the following Monday. The cells have a very limited, they're live cells, so they have a very limited shelf life. They must be administered as soon as they're delivered, or by Friday at the latest. And yes, the DCs, the logistics for DCs delivery to Malaysia is yet to be confirmed. We need to work on that with Edward. We're going to run a couple of dummy shipments from Greece to ensure that the product that arrives does have live DCs within it for you.
Yes.
Yeah.
And if anyone in Indonesia interested, we can also run those dummy tests as well. What they need is an inverted microscope.
Yeah, it is.
For us to.
We need to find a lab in, say, Jakarta that has an inverted microscope to assess the stability and viability of the DCs that have just arrived. So once we can confirm that DCs get into a country live and stable, then the gates are open for subsequent orders. But we don't want to do, RGCC do not want to deliver a product that might be faulty because of a delay or temperature, etc. So it's important that we are able to validate the logistics process as suitable for this particular therapy. So it is usually administered, again, intravenously or subcutaneously. There are other methods, but they're not that common. And we don't have any practitioners, certainly in Australia, that are using these other methods. Again, the first dose is produced and sent, and at some point down the track, the second dose is there and waiting and can be ordered at your request, and they'll ship it. These are some of the expected outcomes for different cancers, etc. So overall, we can see that DC therapies, where there is a low to medium tumor burden, can be quite beneficial in their effects. So it's generally safe therapy, easy to apply. They're autologous cells and personalized to that patient's cancer. So they're very, very specific. And as much as the vaccine is good, the DCs are better in generating a immune response. However, the vaccine has a better stability than the DCs. So it's horses for courses. You have different products there that you can apply to the specific needs of the patient. And we must keep in mind that there's always the contraindications and the eligibility requirements of that prerequisite testing. And that's all the key points there. So I thank you for your time, and now happy to take questions.
If this kept happening, I would have thought it would have never worked. But I'm gonna keep doing it until we get one more successful attempt. All right, toast. Do it right. They got such like a slow, controlled speed, like a consistent speed. Usually they're just going wild. This sounds so intimidating.
Maybe anyone that wants to ask the question can raise their hand, and we can unmute you, or you can ask the questions in the chat box. Right, that would be easier. If anyone wants to ask a question, please raise your hand and we will unmute you, or you can ask your question in the chat box. Is there any question from anyone? I see that we have a number of practitioners from Malaysia and Indonesia, and but it's a very innovative and probably new therapy for a number of practitioners. So but it's interesting to see the outcome results.
It's I guess, you know, very, very new, and it might feel like it's out there, you know, type medicine, but from what we've seen, practitioners in Europe and in the USA have been using these products for, yeah, many years, and yeah, the results they're getting are, yeah, there are, yeah, definite improvements in patients' conditions, etc. We only hear good, you know, good things coming out of the use of these products.
Right.
Especially if, yeah, where the patients have minimal residual disease, you know, the low tumor burden, etc., they can be, you know, quite beneficial in further lessening the effects of the cancer.
Any of these results are published, Peter?
Certainly there's a lot of literature, a lot of information on the internet about SOTs.
Yes.
There are quite a lot of studies and trials of DC, and there are commercial DCs out there that practitioners can order, but they're not personalized.
Right. So this is the difference, really. What RGCs is offering.
These are very. These are tailor-made.
Yes. And can you maybe say a few words why that is so important compared to the off-the-shelves product?
Well, yeah, we know that each patient's cancer is unique and different. So, yeah, targeting and making it personalized and specific to what those cancer cells are expressing genetically, you're going after the cells, the targets that are being overly expressed. So rather than just targeting something that may not be expressing a great deal, you're going after the key culprits through this personalized approach.
Yes.
Yeah. As we saw with the SOT, yeah, they begin with 150 targets or candidates, but from the microarray platform that they used to find the expressions of the genes that were highest, they come up with, to begin with, 150 possible targets, but then they narrow them down to eventually the key one that they are going to get the best effect out of.
Right. And this situation might change over time as well. And
well, yeah, we know that, you know, cancer is it's a heterogeneous bunch of cells. So as much as, you know, it's changing all the time. But if you can cut off, you know, its its key
main driver. Yeah, the key driver.
The key drivers,
Yes.
you slow it down considerably. And then obviously with some of the other protocols that you put in place, like the natural or biological supplementations, etc., the potential of hypothermia, where if their epigenetic expression suggests that they'll benefit from hypothermia, all these different things put in, they'll all help to some degree.
Yes. Yes. That makes sense. Fantastic. Great. And it doesn't appear that there are any questions from folks. So your explanation must be pretty clear and lucid.
I did try.
But we will send out your material, and even the recording, we will have that to the folks, and and I'm sure there'll be further questions we will send to you. Peter is our consultant. For those practitioners who want to run the test and even the therapy, we can arrange with Peter and even with RGCC's practitioners directly in Greece as well. We can set up an account for you, practitioners, and link an RGCC account directly. Yeah. So
as I explained a couple of weeks ago, pardon me, we are happy. Yeah, even in Australia, our practitioners are relatively new to this, and they need our guidance and our assistance and support. And we're happy to provide that. If we get some sort of clinical history on the patient, we can then make recommendations or suggestions as to, is it an oncotrace test that you might want first? Is it one of the other tests, or based on the set of results that you get back as well? Is it something we should? Is an SOT therapy suitable or appropriate? We can give you. We're happy to give you that guidance. So you're not alone.
Indeed. Yes. Fantastic. So really, to sum up, you have at your tool a very precise, customized, not only diagnostic tool, but a therapeutic tool as well, to really tailor precisely to the unique condition of each patient, and that is how the therapy should be, right? Looking at the
one size does not fit all.
Indeed.
Indeed. I that's one of the phrases I learned very early on, when I first got into a different area for natural hormone replacement therapy. It was made very clear to me that that too is going to become personalized. Not one dose of hormone fitted everybody. That counted stuff was personalized, and
But sadly, really, that is the landscape for cancer therapy. Still currently being practiced. The success rate is so poor, right? For chemo and everything.
This is true. This is true. The traditional schools follow certain protocols. They don't dare deviate, etc. But where does the patient end up? This is the question. As Dr. Papasotirio says, my primary task is not to cure the cancer, it's to keep the patient alive. And that resonated, very much with me, that yes, this is the important thing, to keep the patient well and alive.
Well, yes, not only alive but well.
in a good quality of life, rather than a poorer quality of life, let alone dead. But yeah, so this is why he has developed his organisation, and I also see it that he must be doing something right and must be getting good results globally, because his product is growing and becoming more and more credible over time. If his product was more research-based and less practical, so to speak, he wasn't getting the appropriate outcomes, his practitioner base would have deserted him a long time ago, you would think. But he's growing, and he's growing from strength to strength, which suggests to me, with my years of laboratory experience, that he is doing something right. He's onto something correct, and he's well supported by the practitioners that use his products, because ultimately they're getting the right results in their patients.
Yes.
That's one of the things where that's also important to us at Nutripath, that we are aligned with good quality products, because ultimately it's as with you, it's our reputation.
Indeed. Can't agree more.
Yeah, we're not here for a short time. We've actually been here a long time.
Indeed. So I hope all the practitioners and patients will check this out. What we have with RGCC is a very precise way of very early detection, very precise way of looking at all the different expression of these CTCs of cancers, and a very precise, specific treatment that might be suitable for different types of cancer, different stages for different patients. So these are all based on diagnostic tests, and the therapy then is ensured to be accurate, and to have that a good outcome, right? Fantastic. I think that is fabulous, Peter. Once again, thank you so much for sharing your knowledge with us, and this dialogue will definitely continue. We will try to test things out in KL to offer a wide range of therapies that are possible. We need to check out the DCs, but certainly the SOTs and others are possible, and we'll work with our practitioners in Indonesia and other part of the region as well to do that.
Sure.
All right.
Look, if just on Indonesia, if it comes to the point where there are going to be referrals, etc. Yeah, we will need to organise the appropriate paperwork and logistics process, etc. That's all.
Yeah.
We have it all in place, but yeah, that's done. Yeah.
Yeah. Just let me know. I'm a Dr. Edward Chan at WellLab. For those of you that haven't met me, and we are always at your service in the region, KL, Indonesia, and throughout Asia. So with this, I think it must be getting late for you, Peter. So we don't want to hold you up.
Saturday tomorrow, it's fine.
Saturday for you, yes. Okay.
Yeah.
But yeah, and we'll maybe organize something more in the future.
Yeah, sure. If
But
it's
certainly,
me,
yeah.
if it's Benita,
And certainly we would love to have you to come over to KL.
well,
I know,
I look forward to that. To presenting this sort of stuff in person. Hopefully we're all going to stay safe, and they're going to open the borders, and we'll all get to see each other in person again.
Sure. Okay, then we'll say good night to you then, Peter. Right. Thank you so much, and yeah, stay safe, everyone.
Bye bye.
Bye bye.